Hello everyone, I'm Corey Sullivan and I'm one of the product specialists here at Haas Automation. Welcome to part 1 of our How to Set Up Your Haas Robot Package series. In this video, we'll be covering how to set up and configure your robot in the Haas control. To get started, let's navigate over to the Devices tab in the Current Commands page. If you have a Haas Robot Package installed, you will have 2 additional tabs here, the Automatic Parts Loader tab and the Robot tab. For this video, we are going to be covering the Robot tab to tell our machine how we have our robot set up. The Robot tab contains 3 sub-tabs: Frames, Jogging, and Setup. Let's start with the Setup tab. At the top of the window, next to the picture, you will see a prompt to press F1 to connect. And underneath that, the current status, IP address, and maximum payload of the robot. There is also a status icon for the robot displayed to the left of the system clock at all times, so you don't have to navigate back here to see the status of the robot. To do that, first we are going to press the E-stop and make sure the robot controller is powered on. If you just powered on your robot controller, give it a couple minutes to boot up. Then we can press F1 to connect the robot to the machine. After a few moments, the status of the robot will change from disconnected to connected, and the IP address and maximum payload will be displayed. The robot status icon will also change from red, which means disconnected, to yellow, which means that the robot is connected, but there is an alarm or an error. We can now turn off the E-stop and press reset to clear the alarms. The robot status icon will change from yellow to green, indicating that your robot is connected and ready to go. Now that our robot is connected to the machine, let's start telling the machine how we want our robot set up. Underneath the picture and robot status, there are tables asking the user to fill out information. The first row in this table is called Max Robot Speed. This will be the maximum speed that you want the robot to be able to move at, up to 4,000 millimeters a second. Use this if you want to set a speed limit for the robot so that it cannot be programmed to move faster than you want it to. We usually suggest starting with a value of 250 millimeters a second or 10 inches a second when you are first learning how the robot operates to minimize the chance of collisions. This is a fairly slow speed, but you can always increase the speed later. Next is gripper net mass. The robot needs to know how much weight it is carrying to properly calculate its acceleration and deceleration. The gripper that comes installed with Haas Robot Package 1 weighs 6 pounds, so we will enter 6 here. The next row is for the number of grippers installed on your robot. The number of grippers will change some of the options you have available when programming your automatic parts loader sequence. We will enter 1 here since we are using the standard single gripper setup. Now we have to input how our grippers are set up. Each gripper requires 4 rows to be filled out. The clamp and unclamp output rows are asking you which airport on the robot the clamping and unclamping airports on the gripper are connected to. The LR-Mate 200 ID robot that comes in Haas Robot Package 1 has its airports labeled on the arm itself: 1A, 1B, 2A, 2B, 3A, and 3B. For the clamp and unclamp rows, output 1 is equal to 1A, 2, 1B, 3, 2A, and so on. Clamp delay will be the amount of time in seconds the robot will wait to move after clamping or unclamping the grippers. We recommend starting this off at 2 seconds. The last setting for the grippers is clamp type. You can select a grab on the outside or the inside of your part or stock. And that covers everything in the Setup tab, so let us head over to the Jogging tab. In the Jogging tab, you will be able to jog the robot using the touch remote jog handle. Make sure you are in handle jog mode, then go to the Jogging tab. Using the touch remote jog handle, I can select which axes or joint I want to move and the speed at which I want to jog. Press and hold F2, then press and hold either of the arrow buttons or turn the jog wheel to joggle on the selected joint or axis. Touch the button at the bottom left of the touchscreen on the remote jog handle to switch between linear and joint jogging. At the top of the Jogging tab, there is a box displaying the current position of the robot. The first row in the table below will change how this is displayed. Coordinate type can be set to either joint or Cartesian. Cartesian will show the position of the gripper end of the robot in X, Y, Z, W, P, and R axes. X, Y, and Z will be familiar to most machinists and are the linear axes, while W, P, and R are the rotational axes, or yaw, pitch, and roll. Joint coordinate type will display the angular position of each individual joint of the robot as a J1 through J6. The next two options, tool frame and user frame, are where you will be selecting the frames used for jogging the robot. When we get to the Frames tab, we will show you how to create new frames to use here, but for now, let's continue on through the rest of the jogging tab. The next row down is where you will input your desired maximum jogging speed. Here we recommend a max jogging speed of 5 inches a second or 125 millimeters a second as a good starting point. Input the weight of the part being held in the grippers while you are jogging in the single part mass row. Now let's go over to the Frames tab, where we'll be creating new tool and user frames. Tool frames are used to set the position and orientation of the tool on the end of the robot arm or tool center point. The tool frame is a similar concept to the tool offset on your CNC mill. The value we set here tells the control how far our grippers are and which direction they are facing in relation to the faceplate at the end of the robot arm. The first tool frame is called World Frame and is the default frame. All user-created tool frames will be an offset from the World Frame. The World Frame is located at the center of the faceplate at the end of the robot arm, with Z positive coming straight out of the end of the arm and X positive towards the origin point on the faceplate. Let's scroll down to Tool Frame 2 and press Enter to create a new tool frame using the Direct Entry method. The box that pops up for Direct Entry method asks you to name your new tool frame. Then input offsets for X, Y, Z, W, P, and R, relative to the World Frame, to create your new tool frame. First, I'll name this tool frame Grippers. In this example, we have the single grippers that come standard with the Haas Robot Package 1 installed. We can create a tool frame at the end of the gripper fingers by entering an offset of 6 inches in Z, then pressing Enter. I don't need to worry about the other axis values besides Z for this setup with the default single gripper. Now let's go back to the jogging tab so we can see how changing to our new tool frame affects control of the robot. If I stay in World Frame and move the robot around its W or P axes, it will rotate around the center of the faceplate. Now I'll select our newly created Grippers tool frame and jog the robot around the W and P axes. The arm will now rotate around a point 6 inches from the end of the robot arm, roughly at the center point between the end of the gripper fingers. This will make it easier for me to manipulate a part held in the grippers. If we had the optional dual grippers installed in a robot, we could create separate tool frames for each gripper. User frames are used to set a coordinate system around a fixture or work holding, similar to a work offset in your Haas machine. Just like with tool frames, the default user frame is called the World Frame, and each user-created user frame will be an offset from the World Frame. The World Frame origin point is at the center of the base of the robot, with X positive going away from the robot's cable connections and Z positive going straight up away from the mounting face. Try jogging the robot here in the Jogging tab, with User Frame set to World Frame to get a feel for it. Since our robot in Haas Robot Package 1 comes mounted at 30 degrees on the stand, our World Frame Z and Y will move on a 30-degree plane relative to the parts table. X positive will move away from the machine and Y positive will move towards the operator. Let's go back over to the Frames tab to create a new user frame that will reference robot motion to a plane parallel to the parts table, and we'll also flip our Y and X positive directions to make them similar to controlling a milling table. Scroll over to a blank user frame and press Enter to create a new user frame using the Direct Entry method. In the comment line, I'll type in Parts Table to give that name to my new user frame. Then I'll input a negative 30-degree offset for W to compensate for the 30 degrees our robot is mounted at. Last, to flip the X and Y directions, I'll input a 180-degree offset for R and press Enter to create my new user frame. Let's head back to the Jogging tab and select Parts Table as our active user frame. X positive will now be going towards the machine, Y positive will now be heading away from the operator and parallel to the parts table, and Z positive will be going upwards perpendicular to the parts table, just like we wanted. Since we did not set an offset for X, Y, or Z, the origin point is still at the center of the base of the robot. We usually use the direct entry method for setting up our user frame, since it's often the quickest and simplest method. But there is another option if you need to physically reference a particular work plane. This is called the 3-point method. Back in the Frames tab, let's highlight an empty user frame and press Insert to create a new user frame using the 3-point method. First, we will enter a name for this frame. I'll name this one 3-point, then press the right arrow to go to the first point we need to set. The first point is the origin point, and we'll set the X, Y, and Z 0 points for this frame, and record. The next point is the X direction point. We will move the robot in the direction we want our X positive axes to be and record. The last point we need to record is the Y direction point. We need to move the robot in the Y positive direction we want for this frame and record this point. Now we can press Insert to create this new frame. That's all we have for you in this video. Join us for part 2 of this video series, where we will show you how to tell the robot how your parts table is configured.